Hello and welcome. In this video, we'll be discussing how you can utilize OneTrust to discover your data and map it into your data catalog. To kick things off, we'll begin by selecting a system. What you see here in the gallery represents the web apps, databases, and file systems and file shares that are most common with our current customer base. So this is a gallery that continually expands. Beginning with one of these pre-existing connectors here, we'll define our connection name and select our saved credentials. One thing to note here is that the actual processing, actual scanning of this data would be occurring behind your security protocols within your own environment. We're just controlling the scope and the schedule of the scan within the OneTrust platform. Detailed settings are going to be saved and reused within what we call our scan profiles. The first thing to take note of is here at the top under scan type. This would be either a catalog scan or a catalog and scan run together. A catalog is really a metadata scan looking at the schema, the structure, the context of a system, and then the scan is looking at the data element level. So matching the actual data within your systems to known patterns of data in order to accurately categorize what you're storing and interacting with. Down below, we're looking at the scope of the scan. And this is, of course, going to change system to system. We're looking at Amazon S3, so we would be controlling the limit of the scan based off of things like buckets and files. This would, of course, differ depending on that system. We can also look for specific locations. So if I already know where I'm storing certain pieces of sensitive or personal data, I can go ahead and prioritize those locations. And I can also exclude anything that would not be a priority here. When our scan is completed, we'll see the results here within the review screen. On the left, we'll be looking at the results of that catalog scan type, so the metadata returned from our systems, including the specific locations and context here. And then on the right, we're looking at what the scanner has observed about the data elements that are being stored, so the actual categorizations that we've applied here. I can jump in to look for some greater detail. So for example, this phone number that's been applied here to this cover letter, I can expand this out in a review. So I can see both the metadata here by default, and I can also enable sample data. So if I want to make sure that that is a viable phone number here, I'd be looking at a sample or a few small samples and can use what I see in order to approve or to select a more appropriate term from the dropdown. The terms themselves are a mixture of predefined and configurable classifications. These classifications are simply patterns of data that can be grouped logically. So for example, if I want to scan a data source with GDPR in mind, I would be looking for certain types of personal data. Each individual classifier in this group, like country, credit card, date of birth, driver's license, just represents a specific pattern that I want to look for and match against. You can also use our classification builder. So if I want to add in a new classifier here, I can determine what makes up a more unique piece of data. So if I want to look for intellectual property as opposed to something like a credit card number, I can call out the individual terms, abbreviations, pieces of metadata that would indicate that type of data might be present, and then use discovery patterns in order to more specifically look for that type of data. And this can range from something like a lookup, where I can define certain identifiers, certain codes I might be looking for, or it can be something like a regular expression, determining a difference in an ID from a social security number, or even something like an AI model or a digital check. So I can look specifically for religious information, health information, based off of these predefined models. This makes it very user-friendly and very easy to define any type of data that you would want to specifically identify in your systems. The classifications and the connections that we make within the discovery process then flow into the data catalog. A user can perform a simple search of the catalog. So if I want to understand how we define social security numbers, how we store and interact social security numbers as an organization, I can perform a simple search here and jump into the actual term. The first thing I'll see is a brief description, formatting examples, and then of course where this is actually stored and found. Under data assets, I have a list of the precise location and then the main data source where I'm finding social security numbers. And this introduces us to the two main components of our data catalog. The first is the glossary, where we're seeing these terms defined. And the second is the data dictionary, where we see the precise data sources laid out, mapped out, exactly as they're structured within our environments. The glossary here is listing out each term that we use as an organization with the status, so whether it's been recently proposed, approved, under review, etc. Here, we can jump into each to view the similar description and layout as that social security number, and create or suggest our own. I can define a term as a data element, business term, acronym, KPI, and so on, assign it to a particular glossary, so I can create additional glossaries for different regions, departments, even roles, and then it will go through an approval process, with the end result being the approval and that single source of truth for that type of data. The second main view of our data catalog is the data dictionary, which follows individual systems, showing you how they're structured and how data is found throughout them. Jumping into MySQL here, the first thing that you'll see is general information, location information, ownership information about the system itself. This is our highest level information just about MySQL. And as we dive into our child objects, we're going to get more and more specific. What we see here is going to be specific to the type of system that we're looking at. MySQL is of course structured, so we're looking at databases. If we're looking at something like OneDrive, we would see files and folders here. I can dive into a particular database and see the individual tables broken down, and then finally within each of those tables, see the precise columns. So the original column name, the original metadata associated, and then what we've identified based off of that data discovery process. One of the things that first sticks out to me here as I'm reviewing this information, I see account number up at the top, and then I see another account number in another column. Seems like we've found the same data multiple places. What I'll want to do in cases like this is assign out a task. Here I'm assigning a review process to an individual user. Can this information be condensed down? Can this be more logically stored? Just some next steps to enforce best practices here and double check for data quality. Another thing that I might want to know is how this information came about. What other tables does this information impact? Just a larger view of how I'm using this information, where it might be linked to, etc. So I can jump into lineage, and I can view for this particular system how we're using information, how we're linking information based off of primary and foreign key relationships. So here I have this account information table, and it's connected to customer banking, sales information, customer analysis through these keys, giving me a better picture of what other next steps I might need to take into account and how this information is impacting other areas in this system and in our organization. Finally, we can keep track of trends that we've discovered and cataloged within our robust dashboards. For additional information on OneTrust data discovery and data catalog, please visit my.onetrust.com.